numpy elementwise outer product with sparse matrices. I want to do the elementwise outer product of 3 or 4 large 2D arrays in Python. Values are float 32 rounded to 2 decimals. They all have the same number of rows n, but different number of columns I, j, k. The resulting array should be of shape n, I, j, k. Then, I want to sum each column of the result to end up with a 1D array of shape I, j, k. Thanks to Virancy and Divakar, I got a piece of code that works. Problem 1 Performance. This takes about 3 seconds, but I have to repeat this operation many times, and some of the matrices are even larger in number of rows. It is acceptable, but making it faster would be nice. Problem 2 My matrices are sparse. Indeed, for instance, A contains 70% of zeros. I tried to play with sparse_matrix, but really could not get a working version. To get the element-wise outer product here, I go via a conversion to a 3D matrix, which are not supported in sparse_matrix. Problem 3 Memory usage. If I try to also work with a fourth matrix, I run into memory issues. I imagine that converting this code to sparse_matrix would save a lot of memory, and make the calculation faster by ignoring the numerous zero values. Is that true? If yes, can someone help me? Of course, if you have any suggestion for a better implementation, I am also very interested. I don't need any of the intermediate results, just the final 1D result. It's been weeks I'm stuck on this part of code. I am going nuts. Thank you. Edit after Divakar's answer. Approach number 1. Very nice one-liner, but surprisingly slower than the original approach. On my test dataset, approach number 1 takes 4.98 s plus minus 3.06 milliseconds per loop. No speed up with optimize equals true. The original decomposed approach took 3.01 s plus minus 16.5 milliseconds per loop. Approach number 2. Absolutely great, thank you. What an impressive speed up. 62.6 milliseconds plus minus 233 microseconds per loop. About numexpr, I try to avoid as much as possible requirements for external modules, and I don't plan to use multicores/threads. This is an embarrassingly parallelizable task. With hundreds of thousands of objects to analyze, I'll just spread the list across available CPUs during production. I will give it a try for memory optimization. As a brief try of numexpr with a restriction for one thread, performing one multiplication, I get a runtime of 40 milliseconds without numexpr, and 52 milliseconds with numexpr. Thanks again.
Approach number 1. We can use np.einsum to do some reductions in one go. Also, play around with the optimize flag in np.einsum by setting it as true to use BLAS. Approach number 2. We can use broadcasting to do the first step as also mentioned in the posted code, and then leverage tensor matrix multiplication with np.tensor. We can also use numexpr module that supports multi-core processing and also achieves better memory efficiency to get first_multi. This gives us a modified solution, like so. Timings on random float data with given dataset sizes. Just to give a sense of improvement with numexpr. This should be substantial when extending this solution to higher number of inputs.